Let's go to page 116, and this is section 10.5. So this has to do with a circle. So you have a circle and you have the angle. So this is called the inscribed angle. So this is A, B, C. So the angle formed by two chords with a common endpoint, such an angle is called the inscribed angle. So angle ABC is equal to half of the arc. Okay, so this angle is half of the arc. So inscribed angle is half the arc. Whereas if you have the central angle, I'm just going to call that, let's call this D. So angle AOD will equal to the AD. Okay. So again, if it's a central angle, it will equal to the arc. If it's the inscribed angle, that means the vertex is on the circle, then this will be half of that. Okay. And it's easier to see if it's like this way. Okay, so it's more obvious if it's put it this way. Okay, so you can see this would be half of that. Okay, the next thing is you have all different kind of situations. Okay, so when you have a circle, okay, you can have, let's do it differently. Okay. So you can have the angle like somewhere over here. Okay. So this inside, and we already covered this one here on the circle, and then you can have the on the outside. And you can have situation like so again, you got all sort of combinations. So sometimes it can be confusing to the students. I'm trying to do it a little bit better. Okay, and you can even have a situation like this. Okay, so this is X, this is X, this is X, this is X. Okay, I'm going to call this A, B, and this is A and the B over here. Okay, so you got also different situations, but it's very simple. Okay, the thing to remember is if the point of intersection is inside the circle, then the angle X will equal to the half of the sum. So again, if the point of intersection is inside the circle, it will be A plus B over 2. If it's outside, it would be A minus B over 2. Okay, so again, if the point of intersection is inside, is half of the sum. If the point is on the outside, it's half of the difference. So like this one, again, it's outside. The angle, the vertex is on outside. So X will equal to A minus B over 2. Okay, same thing over here. The point is on the outside. So X will equal to A minus B over 2. Okay. Now how about this one here? Is this on the outside or the inside of the circle? Well, it doesn't matter. It's on the circle. Okay. And B equal to 0. So X equal to, if you use A plus B over 2, then this is equal to A over 2 because B equal to 0. If you use A minus B, over 2, again, you're going to get a over 2 because b equal to 0. So if the point is on a circle, then again it's half. Doesn't matter if you, because b is 0, okay? So b is the arc. So b is 0, so it doesn't matter if you add or subtract. You're still going to get a over 2, okay? So again, it's very easy to remember, okay? So if the vertex is inside a circle, you have a plus b over 2. If the vertex of the angle is outside the circle, then it's a minus b over 2, like this, a minus b over 2. So it doesn't matter what kind of, if it's a tangent or it's a secant, okay? And if it's inscribed circle, inscribed angle, so it's on a circle, then in this case, it doesn't matter. You can add or subtract because the b equal to 0, so either way you get a over 2. So that's kind of the summary of the relationship between the angle and the arc.